Hello everybody, how are you doing? Nice to see you today. And today I want you to talk about the so-called quadratic curves. Quadratic curves, it doesn't mean that these curves they are quadratic. It means that all of these kind of curves described by the quadratic expression. Expression with quadratic members. So the members which rise to power 2 at most. They can be the linear, I mean x or y, or they have the cross product of kind of x times y, for example. But at most it should be the second power. So let's start. So quadratic curve here, and the very common way to write down the quadratic curve equation is the following one. It is a times x squared plus b times y squared plus cx times y plus dx e times y plus f equal 0, for example. Here a, b, c, d, e and f are numbers of factors, you can say them. Numbers, factors, some factors. Okay. So the more common situation about quadratic curves, they are circles, ellipses, hyperbolas, and parabolas. Parabolas, for example, parabolas. This is the family of quadratic curves. Today I want you to know about something about circles. So you have your textbook, and you can learn the quadratic curves, their properties using your textbooks. It's very good, it's very clear. And today we consider the quadratic curves only, among quadratic curves, only a circle. So here you have xy coordinate system, xy, and a circle here with the center at the origin point of the xy coordinate system. Here we have 0 point, 0, 0 point. It's clear that the radius of this r is a radius of this circle. It's better to use the small letter, if you don't mind. R small. And the length of the r small is a radius of the curve. Of the curve or circle. Radius vector joins the origin point and the point P at the curve, circle curve, and it has coordinates xy. xy coordinates. You remember maybe that circle is a locus of points which are equidistant from the center point. So it means that if I try to calculate this length of r, radius vector r, which can connect the origin point, the center point of the circle, and the point of this curve, I always have the same number, and it is the radius of this circle. So if I put down x squared plus y squared equal r, so I have r squared, I have here, an equation over circle. So any point P with coordinates x and y, which I mean coordinates turn the expression into equality, we can say that this P belongs or lies at the circle. Since that, this expression is known like equation of the circle. For more general situation, when we have the shifted circle by r0, r small 0, we try to make this a more common expression for the equation of the circle. This is the circle here, this is the center of the circle, this is r0, the radius vector of the center of the circle. And if I take any arbitrary point P with radius vector r small with coordinates x, y, here I have r capital, which is vector which joins the center point and the point at the curve. I can write down that r small equal r0 plus r capital bars. So here we have the vector view of the equation of the circle. Now I can write down that r capital vector of the radius, not radius vector but vector of the radius of the circle, equal radius vector r minus r0. Now I can write down this expression through the components form, and I have here x minus x0 comma y minus y0. I didn't mention, but I denotated x0 and y0, they are coordinates of the center point of the circle. And if I try to calculate the length of this vector, I can say that length of the vector r capital squared equal x minus x0 squared plus y minus y0 squared. Here I use the very classical form of the length, and I can say that this expression I use the is a equation of the circle with the radius r and a center point with coordinates x0 y0. Okay. Sometimes you can deal with the... So this one expression is a canonical view. That is the canonical view of the expression. But sometimes you can deal with the parametric view of the expression. It's very easy to calculate, to write down this expression, especially it is about the first one situation when we are working with the circle which is located to the around the 0, 0 original point of the system of coordinates is the center of the circle. Sometimes you can deal with the parametric view equation of the circle. So if we have circle around the origin of the xy coordinate system, here 0 point, I put here all. So we know that this equation of this circle you can write down through this thing: x squared plus y squared equal r squared, and here you have r. You can see that alpha angle here, that x you can define like r times cosine alpha, and y like r times sine alpha. With this way of the definition of the coordinates of the circle points is known like a parametric how to say it, equation of the circle equation. Okay, equation of the circle. Oh, so since that you can define the circle through the radius and through the center points. Now we can consider some jobs about circles, if you don't mind. Example. So you have, for example, x squared minus 2x plus y squared minus 8y, for example, plus 19 equals 0. And you have a job here. The first one, check if the given expression, if it is a circle. Second one, if it is the circle, if yes, find out radius of the circle and the center point. Okay, if you face this kind of work, you have to add this expression up to the canonical view of the equation of the circle. So we have to transform this given expression into this form: x minus 0 squared plus y minus 0 squared equal r squared. If we are succeeded, we can say that that is a circle and find out the center point and the radius. We have to add these ones expression into this form. How can we do it? We have to allocate the full quadratic form of the polynomial thing. So you have here x squared minus 2x. X squared minus 2x, if you add 2, is exactly x minus 1 squared. Y squared minus 8y, if you add 16, it is exactly the y minus 4 squared. So they don't have here 2 and 16, but we can add them and take away them. And so since that we can rewrite this expression into this form. 2x minus 2x plus 2, I have 2 now, and take away 2, plus y squared minus 8y plus 16, but take away, I have to take away 16, and I have still this 19 here, and all of these things at the left side are equal 0. So now I'm ready to rewrite it into this form. X minus 1 squared minus 2, don't forget about this minus 2, plus y minus 4 squared minus 16 plus 19 equals 0. So I have here x minus 1 squared plus y minus 4 squared, and I can add all the intersection here. They are minus 2 minus 16 plus 19, and all of this thing gives me 1. Now I can move 1 to the right side to make it more close to the canonical view of the expression of the equation of the circle, and I have plus y minus 4 squared equal minus 1. And I have here minus 1 at the right side. You can say that r squared here, it is always positive number. R squared is positive, but I have here negative 1, so it is impossible. If you compare these two things, it's impossible, and I can say that it is impossible because r squared can be negative number, can't be negative number. So the answer here, the given expression can't be an equation of the circle. Example number 2. I have x squared minus 2x plus y squared minus 8y plus, for example, 4x plus 19 equal 0. So I have the same work. So I have to define r squared, I have to define the center point. So all of these things are known for me. And now I have to transform these things into the formula, into the canonical view, the equation of the circle. So I have x squared minus 4x. I don't have 2x. For x it gives me 4 extra and minus 4 element, plus y squared minus 8y plus 16 and minus 16 and plus 19. These three terms gives x minus 2 squared minus 4 plus y minus 4 squared minus 16 plus 19 equals 0. So I have here x minus 2 squared plus y minus 4 squared minus 4 minus 16 and 19 gives minus 1, and all of these things equals 0. And if I move minus 1 to the right side of this equation, I have my x minus 2 squared plus y minus 4 squared equal 1. And if you compare this uh, this expression with the canonical view of the equation of the circle, you can see that two, it is x0, 4, it is y0, and 1, it is r squared. So we can write down here that x0 equal 2, y0 equal 4, and r squared equal 1, since that r equal square root of 1 and it is 1. And the center point has coordinates 2, 4, 4. The center point. I can make very schematically this situation and write and try to draw this circle, if you don't mind. I have x, y coordinate system. The center point, it is 1, 2, and 0, y 1, 2, 3, 4. So since that 2, 4, it is the center point here, and the radius of this center point is 1, so this is radius equal 1. This is the given circle. Example. For example, you have x minus 2 squared plus y minus 3 squared equal 25. And you have a work, evaluate the intersection coordinates of intersection of the given of the given circle and axis x and y. So here I have schematically view here. If we have the center point, I don't know, this circle can be like this one, and we have here some intersection point, intersection. I do not like P1, P2, and P3, P4. So we have here maybe 4 points of intersection. Sometimes we can have no one intersection point. For example, if radius is quite small, so there is no intersection. Sometimes the circle can touch only one of the axes, and we have just one. No, I don't say it how to say intersection, but one touch point here. Intersection, okay. Section point. So we have here 4. Sometimes we can have just 2 intersection point because it can intersect only one of the axes. We can find out this intersection point. If it is about P1 and P2 points, P2 points, we know that y equals 0 here, because both of these points lie at the axis x. Since that, we have x minus 2 squared equal 25. It gives the x coordinates of intersection. P2 and P4 points. Otherwise, we have here x equals 0. So we have result y minus 3 squared equal 25. This one expression gives the y coordinates of the intersection. So that is your homework, home assignment. Calculate or evaluate evaluate the x and y coordinates of the intersection points. That's all. See you later. Good luck. You have your work. You have the ability to ask me something during our tutorial service. Then it goes on. See you later. Good luck.